Alright, so in the previous video we talked about what's happening and why it's happening, and now we're just on to the examples. Okay, I'm going to do quite a bit of highlighting and all of that kind of stuff as we go through the examples. Okay, so make sure that you are staying with me. So here we go. On this first one, we are looking at the central angles. Remember, central angles are named with 3 letters, and the center point has to be in the middle. So first one we could have is WQX, this one right here, and we would say angle WQX. Okay, then we're just going to work our way around the circle. So our next one would be we've got starting with X, then we got Q, and we're ending with Y. Next one on this, across from WQX, we have angle YQZ. That would be this angle right here. We use 3 dash marks in our hoop, and then we've got our last angle, which would be angle WQZ or ZQW. Now, I've had some people ask if we could have straight angles as central angles, and you can, but we're not going to see that as often. So naming like WQY or XQZ, we just want to be a little more careful about naming those. Okay, now our second part here, we've got semicircles. Okay, remember semicircles we're naming with 3 letters. Okay, and semicircles are our half circles. Okay, so to look at our half circles, we need to first look at our diameters. Okay, so there's one of my diameters. So if I'm looking at this semicircle along that diameter, we've got to start at W and end at Y. So what we're looking at is if I start with W and end with Y, then what goes in the middle is that third letter that's in between W and Y. So on that top half, that would be X. So arc, WXY, could be one of our semicircles. Okay, then we can look at the bottom half. And again, we have to start with W and end with Y. Or you could start with Y and end with W. But now Z is going to be inside the W and the Y because that is in between right here on your semicircle. Okay, so there's 2. Now we've got to have 2 more. Our 2 other ones are going to come off our other diameter right here, XZ. So on both of these parts, we have to have X at the beginning or end and Z at the beginning or end. So X at the beginning or end and Z at the beginning or end. Okay, so one of our semicircles here would be going from X to Z this direction, which means W has to go in the middle. And then our other semicircle would be going the other direction, X to Z, and now Y is in the middle. So those are your semicircles. Okay, now our minor arc is named with 2 letters. Okay, named with 2 letters here. I'm going to erase this semicircle mark. Okay, so minor arcs, 2 letters, less than 180. I personally think these are your easy ones. So we would have WX, then we have from X to Y, then we have from Y to Z, and then we have from Z to W. Now remember, you can always name those forwards or backwards, whichever way you prefer. Okay? So again, that is like right here, that's our minor arc, 2 letters in between them. Now, major arcs are the hardest ones. We're still going to base our major arcs off of the diameter, but now we've got to go from one point to the other point, and we've got to go past it. Okay, so I'm going to color code as we go, okay, just to keep us all on the same page. So if I want to go along the diameter that's purple, the X to Z, if I start at X and go to Z, that's 180 degrees. So to make it major, we have to go past it and end at W. Okay, now in the last video I talked about how I like to name using the diameter, so I'm going to continue doing that. Okay, so we have XZ, and we ended at W, so we would have XZW. Now, that arc can be named a couple of different ways. Okay, the other way you could name that is going backwards, like WZX. Okay, but you could also name this using that Y point. Okay, so we could say that this is also X, Y, W. That would be the same arc that we're talking about right now. Okay, now of course that could also be named going backwards. Okay, so let's look at another one. Okay, still looking at along that purple diagonal. I mean, not diagonal, diameter. Okay, that was my green one, just so that we can keep up with that. Okay, so purple diameter, X to Z. What if I go starting the other way? What if we started Z, and then we could go from Z to X, and Z to X is 180, but then we can go past it to Y. Okay, so that is another major arc that we have. Okay, so I'm going to name it Z, X, Y. But we could, again, name it a couple different ways. We could name it going backwards. Okay, we could name it YXZ. Okay, or we could name it, okay, Z, WY, and skip that X altogether. Okay, so again, a couple different ways to name it here. We've got to be extremely careful when we're naming these. Okay, so the purple letters are my purple highlight, okay? Alright, so let's go for number 3. Okay, our third one, you could stay on that diameter. Okay, and we have a couple more options here. Okay, we could start at Z, and we could go to X, and go past X to W. That would work as well. Okay, so if we wanted to do that one, we could name it ZXW. Okay, you could also name that arc ZYW. Okay, or you could name it backwards like WXZ or WYZ. Okay, and then we've got one more that we need to find here. Okay, for this last one, I'm going to use the other diameter. I'm going to use this red diameter. Okay, going from W to Y. Okay, so if we go from W to Y, okay, we already know going from W to Y to X, we already did that one. Okay, but what if we go backwards? What if we start at W and go to Y, and then we would have to end at Z? Okay, do we have that one? Yeah, we already have that one. That is our blue arc. Okay, so we need to make sure that we're being careful. Okay, so let's see if we have a different one. Okay, we could go from W to Y to X. That's our green one. We already did that. So we can't even go along our red diameter. That's what I wanted to point out. Okay, so let's look for one more along our purple diameter. We could start at X. Okay, let's start at X. We could go from X all the way down here to Z. Okay, and then we can end at Y. Okay, and that one we haven't done yet. Okay, so let's call that one x, z, y. Okay, now we could call that also x, w, y, or we could go backwards and say that it was y, z, x. Okay, so remember, major arcs have lots of options. Okay? Now, this next part goes a lot faster. We're just looking at these numbers. Okay, again, it's super important to look at our diameter. Okay, so our diameter here is SP because it goes through this point C. So we know that there's 180 degrees on this side, and there's 180 degrees on the other side. So let's just look at our circle. Okay, if this arc is 45, if this angle is 45, then we know that this arc is 45. If we know that this arc is 60, then we know that this angle is 60. Okay, to find this angle right here, we know that that forms a straight line with 45. So we would have to say 180 minus 45, which gives us 135. So this angle is 135, and this arc is also 135. So then we have to do the same thing on the other side and say that 180 minus 60 is 120, which goes with this arc, and then this angle would be 120. So, let's look at our picture and fill in our different blanks. Okay, so angle PCQ is in the middle, and it's just 60 degrees. It's one that we already have labeled. Okay, arc ST we have clearly marked as 45. Arc SQP, okay, arc SQP is a part of this side. So SQ to P is along the diameter. So this is going to be 180 degrees. Now technically what we're doing is adding 120 plus 60. Okay? Then we've got arc SQ, which is 120 degrees. Then we've got angle SCQ, which is also 120 degrees. Okay, this angle right here. Okay? Then angle SCP. Okay, SCP is right here, S to C to P, and that's along our diameter, which means it's a straight angle, which just means that it equals 180 degrees. Now, we get a little trickier on SPQ. I'm going to highlight our arc SPQ in green. Okay, so S is here. Okay, then we've got P, which is here, and Q, which is here. So we need to start at S and end at Q, which is right here. So there's two different ways that you could do this. You could add all your arcs together, okay, or we know that there's 360 degrees in our full circle, okay, which I think is a little bit easier. So we could say 360 minus the arc that we're not touching, which is 120, and that ends up giving us 240 degrees. Now again, the other way you could do that is add 45 plus 135 plus 60. Okay. Our next one is arc PT, and arc PT we found as 135 degrees. Then we've got angle TCP. You've got to be a little careful on these with TCP and the direction that it's opening. So angle TCP is this angle right there, and that angle is 135 degrees. Okay. Next one is arc SPT. Okay, arc SPT, which means we're starting at S, going to P, and ending at T. So here's S where we need to start. Here's P, and we need to end up here at T, which means we are going counterclockwise. Okay, so when we go counterclockwise here on the blue, we see that we are not including that 45-degree arc. So we just want to say 360 minus 45, which gives us 315 degrees. Okay? Then we've got arc TQ, and arc TQ is from T to Q. Okay? And arc TQ is made up of two arcs, which are 45 and 120, which ends up giving us 165, not 0, 165 degrees. Okay? So, continuing on finding angles, last piece for today says find the measure of each numbered angle where O is the center of the circle. Okay, we know that there's 360 degrees in the whole circle. So if you look here, we need to find this arc before we can find this angle. So we're going to say 360 minus 240, which gives us 120 degrees. And we know that the angle and the arc are the same, so angle 1 equals 120 degrees. Now on number 17, okay, we know that this is the diameter, which means this arc, all the way around here, is 180 degrees. Okay, the hoops and the angles tell us that these are all equal, which means we have 3 equal angles. So we can say 180 divided by 3, which gives us 60 degrees. So angle 1 would equal 60 because all of these arcs would be 60. Now 18 and 19, your last two are extremely similar. Okay, and we've got two diameters, okay, which form vertical angles. So from here to here, we know that this is 180 degrees. So we can say to find angle 1, 180 minus 160 is 20 degrees. So that makes this arc right here in this angle 20 degrees. And then if you know that's 20 degrees, okay, then this other side is going to be 20 degrees because they're vertical angles, which means that angle 2 corresponds with the 160, so this arc and that arc are the same. So we could say that angle 2 equals 160. So looking at number 19, okay, we know that this arc is 40, so this arc is 40. So angle 1 equals 40 degrees. Okay, then we know that this is a straight line, and this is 40, which means we can subtract 180 minus 40, which gives us 140, which means angle 2 equals 140 degrees. Okay, I hope this is giving you some good examples so that you are able to complete the work that you need to. If you have more questions, let me know.